webinar. Welcome. Today, I'm super excited to talk to you about the intersection between long-range weather and energy, both risks as well as opportunities. And of course, who doesn't like a good opportunity? To introduce myself, my name is Dr. Hansi Singh. I'm an Earth system scientist. I used to be a fellow at the U.S. Department of Energy. I was also a professor for several years. And I still participate in Earth system model development at NCAR as a working group co-chair over there. I've worked extensively with major federal agencies leading research initiatives. The reason why I started Planet out of all of this is because I think that specifically in earth sciences, there's a ton of information from the research world that never quite makes it into the real world. And my goal has really been to accelerate this, particularly in terms of long-range weather intelligence. So today, what we're going to talk about is how energy relates to long-range weather intelligence and how we can identify both risks and opportunities. So first, I'll just do a real quick brief on how long-range weather forecasting works. Then I'll talk a bit about the intersection of weather and energy, some of the fundamentals. Then we'll get into some opportunities, particularly around cold snaps, wildfires, and anticipating generation and storage anomalies. And then finally, we will take a look very, very briefly at some of the implications for what the current long-range outlook means for the energy sector. So first, you might be wondering, well, what is this magic of forecasting weather beyond my weather app on my phone? Well, it turns out that the weather app on your phone utilizes a weather model, which is an atmosphere only model. And these models have only about 14 days of predictable power because they rely on initial condition predictability in the atmosphere. And the atmosphere pretty much forgets where it started from after a couple of weeks. The way that we get beyond that into longer range weather, as well as even climate modeling, is through Earth system models. Earth system models, we call them kitchen sink models because they basically have everything and the kitchen sink. Atmosphere, ocean, ice, land, and the ocean in particular has a ton of memory over very long time horizons, and the land and the ice, as well as fuller atmospheres, have much more memory. That brings us into the weeks to months of predictable skill. So these are the kinds of models that we use in combination with various AI-based calibration methods in order to produce super skilled forecasts beyond your 14-day forecasts. Please keep in mind, these forecasts are not day to day, but they can be week to week, they can be month to month, they can be season to season, and they can have a ton of predictive skill. So what are some of the fundamentals here as we talk about weather and energy? So first of all, weather is a huge driver of energy demand and the generation stack. And second, weather patterns are known to very frequently disturb and disrupt energy systems. Let's look at these in a bit more detail. So weather drives energy demand. So once again, this might be preaching to the choir a little bit, but let's just get through this. And so energy demand in particular, residential and commercial plus power, is strongly linked to temperature. So demand for heating, often calculated as heating degree days, or demand for cooling, calculated as cooling degree days, is incredibly temperature dependent. And that temperature dependency, of course, depends on weather patterns, and it has a lot of volatility day to day, week to week, month to month. Beyond that, weather also impacts the generation stack. So in particular, all of our grids have not just fossil fuels on them, but a lot of renewables. And these renewables are highly dependent in terms of generation on weather. So for example, hydropower depends on rainfall plus snowpack. And wind power and solar power both depend strongly on variations in the atmospheric circulation. Very particularly, these types of energy have a lot of year-to-year volatility. So hydropower in particular has up to 50% of year-to-year volatility in the availability of snowpack or the availability of reservoir water. In terms of wind energy as well, we see between 15 to 30% of year-to-year fluctuations in what wind energy is available. And solar has a much smaller year-to-year variance. The point being here is that if you can predict some of this volatility, there is enormous value in terms of understanding how weather can play into the generation stack. In addition to driving generation and demand, weather also can disrupt energy systems. So conservatively, 1 in 2 power system disruptions is due to weather. As we know, weather is becoming more severe with climate change. Our energy infrastructure, unfortunately, is aging and it's not really being updated at the pace that we would need to get to, having that really secure, awesome grid that we would like. And moreover, our energy consumption is growing. So even as, we're trying to sort of play catch up in terms of updating our energy infrastructure, our grids are growing in complexity just to keep up with this growing demand and this growing consumption. And so what this means is that there's just a lot of room for things to go wrong. And as soon as you put weather into the picture, things do go wrong, hence these grid disruptions. A couple of other things to point out too is that weather trends really come into play here. And when I say weather trends, I mean climate change. So when it comes to the generation stack, this generation stack is going to be impacted by climate change. So for example, climate change is decreasing hydropower availability over many parts of the world. So this is looking into mid-century compared to 1950 to 2000. And this is particularly looking at water availability, precipitation minus evaporation. And you can see that regions, for example, that are strong hydro regions, for example, Spain, the American Southwest, parts of Chile, many of these regions are expected to dry. And so what this means is that hydropower is likely going to have to be less of a ingredient in the energy generation stack than it currently is. So it's really important to keep some of these trends in mind. Another area where there are important trends is wind energy potential. Wind energy potential is actually decreasing across many global land regions, and this includes North America, Eurasia, Australia. This is from a paper, Martinez and Iglesias 2024. Particularly where they look at the change in wind energy potential to mid-century. And very particularly, you can just see that like North America, generally speaking, there's been less wind energy there. North America, big parts of Eurasia. On the other hand, we do expect some more wind energy in the tropics. And so, this might be, there might be a lot of opportunities in here as well. Note that year-to-year variability in wind energy is also increasing in terms of weather trends, in terms of the impacts of climate change. So that's another area to keep in mind, that the value of a good forecast is actually increasing because variability is increasing. So finally, we get to net energy demand. Most of y'all probably know this equation that we can calculate the demand for non-renewables on the grid by looking at the total demand due to temperature and looking at stack generation from the renewables. And so the point here is that in the near term, right, hours, days, weeks, months, weather really drives energy markets. Keep in mind, of course, is that as soon as we start looking in the longer term, right, economic metrics like population growth, industrial growth, GDP, the overall sort of macroeconomic picture, geopolitics are incredibly important as well. But in, many of these time horizons, weather is just such a key player in markets. Okay, so now let's start looking at some of these risks and opportunities that we can glean from using long-range weather in conjunction with needs in the energy sector. So first, I want to look at anticipating cold snaps and particularly anticipating them earlier than what you would expect from your usual 7-day weather forecast. So here in this figure, these are natural gas production outages due to Winter Storm Fern, which happened in late January 2026. And you can see that there were a whole bunch of outages that happened and that these resulted in many force majeure declarations and a lot of legal risk for the various suppliers and pipelines involved here and storage facilities. So these types of cold snaps, they can cause a ton of unplanned disruptions to the grid, to dependent industries, to transportation, and they tend to drive really high prices and volatility across energy markets due to the high demand and can often lead to major economic losses. And of course, losses of lives, losses of property, losses of livelihoods. So, what is the science of these cold snaps? So, cold snaps, particularly, are highly predictable. And the reason why they are so highly predictable is because they are linked to the stratosphere, and the stratosphere is very predictable. So, polar vortex weakening events, which lead to cold snaps, can provide us with up to 30 days of lead time in predicting these cold snaps. Because what happens is that we see one of these polar vortex weakening events in the forecast, and then from there, usually with a week or two delay, we see impacts on the surface. And so that gives us up to 30 days of lead time. And so what do these cold snaps mean for, say, the US or for Europe? Well, it means that often we'll see a pattern where we'll see a cold Eurasia, or we'll see another pattern where we'll see a warm Arctic and a cold North America. So these are just kind of patterns that emerge from these stratospheric events, and they are due to sort of the physics of how the stratosphere impacts surface temperatures. And once again, yeah, nature has given us a really nice lead time here, thanks to sort of the physics of how these events play out. So, we have a full case study on this particular storm, Winter Storm Fern, that happened in January 2026. I'm just showing a single figure from this case study, looking at how the forecasts evolved and how natural gas prices across continental US, Midwest, and the Northeast evolved at the same time with the forecasts. So here's our forecast that first showed this particular cold snap. This was on January 1st, 2026. And you can see at that time, prices were very low. And our model continued to have conviction in this cold snap over, the next several weeks until the cold snap materialized. So these are forecasts for the week of the cold snap, starting on the 23rd to the 30th. And so, yeah, these blue colors show sort of colder than usual temperatures. You can see how it sort of evolved in time. And the fact is that the market didn't really start to react until mid-month to this particular cold event. And so the point is that there were probably many opportunities for people to take a look at these forecasts and to take measures accordingly or even take advantage of opportunities. So in particular, if you were in production or storage, if you knew that there was going to be likely to be an outage, these could have been potentially averted as force majeures. So, in other words, preventing force majeures, which are very, costly, as well as have major legal and reputational implications for a company. Moreover, if you were a utility, you could have prepared the grid for winter weather. You could have planned for an appropriate generation stack, and appropriate peaking services to ensure that your grid is reliable and that your customers are getting the energy that they need, the power that they need. And of course, for opportunities, um, paying attention to forecasts would have really allowed you to generate a ton of profitable trades by capitalizing on the fact that natural gas remained relatively undervalued through mid-January. It was only after that that the market sort of caught on that there was likely to be a major cold snap event, even though the cold snap appeared in the forecast quite early. So the next opportunity and risk is regarding mitigating wildfire risk to the grid. So wildfires can damage the grid, but they can also actually, the grid can spark major fires. And in fact, public service grid shutoffs are becoming a norm across many parts of our country. These can really prevent wildfires, but they often drive billions of dollars in costs and losses, especially when they occur with very short notice. And so you end up with unplanned closures, unplanned delays. Basically, just the fact that you did not have the chance to plan for that is much worse than if you had planned. And so, just looking at the science here a little bit, what weather conditions drive wildfires? Well, it turns out that there's several ingredients, and so it's not just a single factor. The first is having excess dry vegetation. This means that you have wet periods followed by prolonged dry periods. And so you end up with a lot of vegetation that can serve as fuel for fires. Then, high temperatures and low relative humidity is also a major factor because these help to dry vegetation and dry soil. And finally, periods of high winds can serve as the impetus to create the sparks that actually start fires in the first place. So let's look at some fires where there was really good lead time, specifically in terms of forecasts. So this is for the 2025 LA fire. So this particular fire led to billions in losses, and there were two major fires. I think yeah, one in Altadena and the other one closer to the coast. And so, with these fires in particular, they were preceded by a prolonged dry period near the end of the year, prior to January 2025, which is when the fire happened. And so, here, what I'm showing is this was the actual rainfall at the end of the year in 2024, October, November, and December. And this is our forecast initialized June 2024 that showed significantly lower than usual rainfall. This is the usual rainfall predicted. And so the point here is that if you were watching the forecast even this early, as a utility, there was probably a fair amount that you could have done to sort of prepare the grid for what would likely be a high wildfire risk year. So, in other words, for periods of drought like this, sometimes there is months of warning that it is likely that rainfall will be substantially lower than normal. A similar example is the August 2023 Lahaina fires in Hawaii. And for these fires in particular, forecasts not only predicted a drought, right, or a dry season, drier than usual season right before the fires. So this is showing the 4 to 6 month lead compared to actual. And not only showed drier than usual conditions, but also even showed the wetter than usual conditions that occurred about 6 months before the fires themselves. So, in other words, there was sort of an indication that, okay, we're going to get a ton of vegetation growth, and then later that we're going to have this dry spell. So, the neat thing is that forecasts are something that you can sort of keep track of and you can watch how they evolve in time. And they can really provide this sort of long range insight to understand what the risks might be and how they might evolve with time as the weather and the background climate conditions evolve. So, one area that is quite interesting is that Florida, it turns out, actually has a substantial amount of wildfire risk. This is the April 2026 map that was just released for wildfire risk. You can see Florida is highlighted here, and this is for May 2026. And so this is actually something that showed up in our forecast as early as January. So this is a screenshot from one of our January webinars where, it was very clear that Florida was going to be dry. And given the fact that apparently these palms really like to burn over there, I had no idea, but this is a thing. I see our Florida scientist nodding over here. He's like, yes, they do burn. And so, yeah, this was something that showed up in our forecast as early as January, that this Florida was going to be dry. And so, likely high possibility of wildfire risk. So maybe something for Florida utilities as well to keep in mind. So finally, I want to get to thinking about the generation stack and reserves, particularly. So I'm going to do this by looking at a couple of examples. First, let's look at winter in Europe, just this past winter, 2025 and 2026. So this was a forecast that we shared in our September 2025 webinar, where we were sort of doing a look at winter over Europe. So we were looking at the January, February, March 2026 forecast. And you can tell that even then, our forecast did identify that Europe was likely going to be colder than usual. And notice that when Europe is colder than usual, they tend to, eat up their natural gas reserves over the course of the winter. And in fact, this is where we are. The reserves have been eaten up. They're quite low. And unfortunately, there's a huge conflict going on in the Middle East right now. And so this is really adding to this problem because Europe has low reserves and likely low shipments that are coming from the Middle East. And so these are just kind of important ways in which weather can interact with geopolitics to sort of just make things even more harrowing. It is possible that this coming year, depending on how long this conflict lasts, that there could be supply risks. Weather plus the situation in the Gulf might throw this region into something of a supply crunch. So in particular, when it came to this forecast, right, the forecast showed this, sort of colder than usual conditions. But in addition to this, the fundamentals really were pointing to colder than usual conditions, particularly because we had a negative QBO, a neutral ENSO. This is also something that we highlighted a lot in September, that it was going to be a pretty active winter in terms of cold snaps. And so, in fact, I mean, this is how the winter has played out. Keep in mind, our forecast for next winter will be out next month. So we're always excited to see sort of what we think the winter will bring. And there's some really strong signals going on right now. So we will have some really good predictability going forward this year. Okay, so final example here. Looking at spring 2026 Pacific Northwest hydro situation. So we had a really interesting situation this year where we had a ton of rainfall. And so this was our actual forecast from November 2025, where, in 2025, or sorry, okay, this is our forecast for November, yeah, November 2025 that was made in September 2025. November is the wettest month of the year here in the Pacific Northwest. And so at that time, we really highlighted, yeah, the forecast showed that it's definitely going to be, or very likely to be wetter than normal. And in fact, when you look at the seasonal forecast next to the actual sort of what the winter looked like, the pattern is almost like identical. Really just highlighted how the Pacific Northwest was going to be much wetter than usual. And so what does this mean? Well, it was wetter than usual. It was also substantially warmer than usual. So even though we got some really good snow over here on the Canadian Rockies, like Revelstoke is just, in many feet of snow right now. So great for them. But it's been very warm over on the coast. And so what this means is that wetter than usual weather plus warmer than usual weather has led to some really historically high water levels in the reservoirs over this part of the country. And so what this means is that combined with low snowpack this spring means that we have a ton of hydro right now. And in fact, we have so much hydro that natural gas prices and power prices are down, for example, in Kingsgate. So we're just swimming in hydro, but I know that by the end of the summer, we are probably going to be in a bit of an energy crunch. And I say that because knowing that we have very little snowpack and that this is just a thing over the entire American West is really going to, probably stress our grid a little bit at least. So anyway, thinking about the future based on current conditions, which is just abundant hydro and very low natural gas prices. So finally, I want to look a little further, particularly into what 2026 will bring in terms of energy. So as y'all probably know, there is a huge El Nino in the works right now, probably by the end of this year. So by, mid Q4, we are expecting this El Nino to be of a super variety, which means that it's two standard deviations above typical. And so, what that super El Nino means is that that signal from El Nino is going to have really strong teleconnections around the world. So, some of the implications for the grid are as follows. First of all, we expect that in Asia in particular, we expect, or I shouldn't say all of Asia, but parts of Asia, so specifically Southeast Asia and South Asia, we expect less hydropower availability than usual because of drought. And keep in mind also that it's not just hydropower. I know this is an energy webinar, but it's going to definitely be agriculture, it'll probably be industry as well, that are going to be affected by having less water availability. The second thing to keep in mind is that in the American West this summer, in particular, thanks to this El Nino and thanks to the sort of marine heat wave that has been developing over close to the coast, this is actually something we've been talking about once again since September. And so now it's actually, usually we see these kinds of marine heat waves sort of mellow out a little bit over winter, but then it is starting to grow again. So this is something that we've been watching since September and really kind of seeing it come to fruition right off of the North American West Coast. And in particular, in combination with this El Nino and this sort of marine heat wave going on, we're going to have pretty warm temperatures over the Western US. And so I mentioned, okay, we have a ton of hydro right now. That's lovely. But we're going to definitely be using a lot of that energy because there's going to be a lot of energy demand for cooling this summer over the American West. So definitely something to keep in mind in terms of the long range outlook. We expect to see this over Western North America and over a lot of South America, as well as elsewhere in the world, thanks to this El Nino. So that is what I've got today. Thank you for being here. If you ever want to kind of discuss other details about the weather, let me know. And we are happy to sort of arrange a call, have a chat. And I want to put in a plug for our next webinar. So this is particularly about managing for weather, looking at operational risks and opportunities. And we're super stoked to have one of Planet's advisors here on as a special guest for this webinar. So he has been a former director and VP of risk management at many organizations, including Live Nation, APL Logistics, and Jacuzzi. So really excited to have Jan, and yeah, this should be a good one. So thank you so much for being here. Here's our YouTube. We post webinars on our YouTube generally a few days after we go live here. So yeah, you can follow us on here. You can find us on LinkedIn, and yeah, feel free to message me if you have any questions. Thank you so much. Are there any questions in the chat? Okay, I see a couple of questions. Okay, we had a question about, is this the forward AGT price or spot? So we had an excellent advisor in the energy space that has helped create these particular some of these analyses. that we did. And so I'm wondering, I see that that's at 944. So I'm guessing that maybe that is regarding this figure. I think this is BALMO, which is the monthly balance. Is that the question that you have, Benjamin? I'm not sure if Benjamin is still on the call. Okay. Yeah, I don't know. Okay. Maybe I will message Benjamin afterwards to answer his question. And then I see Dr. Femi asks about whether climate change has been included in these forecasts. And yes, it's all included. Because these are Earth system models, essentially like climate change, in other words, addition of more greenhouse gases into the atmosphere is already included and taken into account when we make our forecasts. All right, folks, thank you so much. Really appreciate your attention here and look forward to keeping in touch with many of you.